In this video, I'm going to show you how to use the PID controlled rack and pinion cart pendulum disturbance module in the Control Theory Virtual Lab. Each module uses a PID controller to control the position or path of a specified mass. The cart disturbance module consists of two equal pendulums connected to a cart. The cart is connected to a rack and pinion, which is actuated by a random signal generator or a pulse generator. These signals move the cart, which disturbs the attached pendulums. One pendulum is PID controlled with a desired position of 0 degrees, meaning it is being kept vertical, and the other is free response. When the folder is downloaded, all the necessary files are included. The folder consists of the Control Lab SLX file, 13 step files, and 2 data file mat files. For the module to work correctly and load all the necessary solids, all the step files must be on your MATLAB path. This is achieved by either having all the files in the same folder and opening it as your current folder, or by manually adding the files or separate folder those files are in to the MATLAB path. If the files are not on your MATLAB path, this error will appear when you try to run or update the simulation. To select the cart disturbance module, click its blue title, then double-click the now highlighted box. In this window, you can change the length of the pendulum rod and the mass. The Position Scope button opens a graph which shows how much the pendulums rotate in degrees in response to the disturbance versus the simulation time. The yellow line shows the rotation of the controlled pendulum, and the blue line shows the rotation of the free pendulum. The PID Control button opens the PID controller where you can change the proportional, integral, and derivative constants. You can either change the constants manually or use the Tune button to let MATLAB calculate the values. Make sure that Select Tuning Method is set to Transfer Function Based. Click Apply at the bottom of the window and then click the Tune button. Once the PID Tuner app loads, you can simply click the green arrow button to update your PID controller with the new values. Or you can use the response time and transient behavior sliders to adjust the tuned response. Then use the green arrow to update the PID constants. Once you are satisfied with the response, you can click Apply and run the simulation. For this example, we are using the pulse actuation with an amplitude of 40 degrees and a period of 2 seconds. These are the PID constants we'll use for the first simulation. Remember to click the Apply button at the bottom of the PID controller window after changing any of the constants. Here we can see both pendulums swinging in response to the moving cart. Once the simulation is finished, you can use the Position Scope button to compare the movements of the controlled pendulum versus the free pendulum. You can also save the simulation data in your MATLAB workspace to compare it to other systems. For example, I'll change the PID constants using the Tuner app and its sliders and run the simulation. I'm using these sliders to decrease overshoot and response time. Now we can see that the updated PID constants are having a larger effect on the position of the pendulum. I'll save the data of the second simulation in the MATLAB workspace. Now I'll compare the response of the controlled pendulum with my values to the response of the controlled pendulum using the tuned values. We can see that using the tuned PID values, the pendulum in red returns to the desired position much faster and with less overshoot after each pulse. The blue response, that used the 100 PID constants, oscillates about the desired position and rotates much farther. This virtual lab helps students see the effect each constant has on a system by letting them run many experiments very quickly, and allowing them to easily save and compare different systems. Thank you for watching.